biggest way our design has changed during this phase is the things that we have designed to increase the sensitivity of the system. When we are operating at W1 and W2, the WEC is barely moving because the sea state is so low. So we've had to do things like design custom valves. We've had to modify tubing sizes and length of tubing runs, things like that to try to make the device sensitive enough for the ultra low, irregular sea state. The most exciting thing in the competition was when we finished our test rig and were able to make the device come alive. The rig will oscillate the unit as it would be oscillated in the real sea. And that was probably the coolest part of it, was to actually see it start to move and start to produce water, which it did. We're far from being complete, but that was the best part, to show that there was legitimate, tangible progress.
Freshwater production by reverse osmosis is new to the team, and this poses a considerable challenge, even though the theory itself is well understood within the team. The prize funding allows us to mitigate this challenge. We will build a fully operational water maker with sufficient design flexibility and measurement equipment to allow us to determine the actual performance under close to real conditions. Because the team is fully committed to solving the technical problems, whether or not we advance to the next round, there's no doubt that thanks to the support and encouragement from the DOE and the NREL, considerable research will have been done by the end of the project, and this is invaluable.